Hello class, we are now going to cover Chapter 7, which is on sedimentary rocks. So sedimentary rocks are rocks forming from the deposition and lithification of sediment, which forms from the process of weathering as we saw in the last chapter, and then after that these sediments get eroded from those previous rocks. So sedimentary rocks are features that are found in the crust and are really mostly close to the surface. They're surface type of rocks for the most part. All right. Most of solid earth consists of igneous and metamorphic rocks, but geologists estimate that both of these together make up about 90 to 95% of the outer 16-kilometer crust. However, despite this large amount of igneous and metamorphic rocks that are in the crust overall, the Earth's solid surface consists of either sedimentary rocks or sediment for the most part. So about 75% of land areas are actually covered by sediments and sedimentary rock, leaving only 25% to be made up of igneous or metamorphic rocks at the surface. Across the ocean floor, which represents 70% of Earth's solid surface, virtually everything is covered by sediment, even though beneath that sediment is mostly igneous rocks, as we saw in Chapter 4. So igneous rocks are really only exposed at the crests of mid-ocean ridges, at large igneous provinces, which have been uplifted and exposed, and in some volcanic areas, which overall is not very much of Earth's surface. And then metamorphic rocks tend to only be found in mountainous areas. So, although sediment and sedimentary rocks make up only a small percentage of the Earth's crust, they are concentrated at or near the surface, which is that interface between the Earth's four spheres, between the atmosphere, the hydrosphere, the biosphere, and the geosphere. So, very important. Because of this position, they contain evidence of past conditions and events at the surface. So through the textures, the shapes, the compositions, and the structures of, for example, fossils that are preserved in these sedimentary rocks, along with the rocks themselves, large inferences about the past conditions on that location of the Earth at the time those fossils were buried can be made. And some of these observations that we make can be correlated to many fossils if these occurred elsewhere in the planet as well. So sometimes just studying the rock's nature helps to find these correlations, not necessarily with the aiding tools as fossils are. Sedimentary rocks, or still somewhat unconsolidated sediments, are also the places in which we find most of our groundwater resources. So understanding the properties of those rocks aids us in using these resources properly. And as you know, groundwater is super key. I think as we saw a little bit for Chapter 1, we saw that groundwater was one of the biggest reservoirs of fresh water that is available to us in the liquid form. And another resource that mostly resides or is part of sedimentary rocks that are fossilized, organic derived, are energy sources such as coal, natural gas, and oil. So coal is itself a sedimentary rock found at some depth, but typically not much depth if at all. Oil and natural gas are usually created at a specific depth within the earth and sometimes migrate upwards, but many times they actually just reside in sedimentary rock reservoirs, they're called. And these are capped by some sort of sedimentary rock, sealing rock. We'll discuss both of these things, the coal formation and the natural gas and oil formation, later in the chapter. So if that was a little bit confusing, don't worry, because we'll touch base on it again. So other resources we use as a society on a daily basis are sedimentary rocks such as gypsum and limestone. And we'll cover these later in the chapter as well. So, all in all, sedimentary rocks are the rocks that we as a species probably have the most interaction with, and out of which we take the most advantage or are harmed by the most in certain natural disasters, for example. So understanding sedimentary rocks and the processes that make them and that erode them as well, and weather them, is very key. Referring back to our rock cycle from chapter 1, if you guys remember, this is it. Sedimentary rocks are formed from the deposition and lithification of sediments. And this can be seen by the arrows in the graph that you have above. Sedimentary rocks only form by the previous weathering of some other pre-existing rock. So before they become sedimentary rocks, they were sediment or some particle of another rock, and after getting reworked, turned into that sedimentary rock. And we'll look at the process with more detail as we cover the chapter. If we look again at these 7 steps needed for the sedimentary rock formation process, which we covered in chapter 6, we will see that there are many conditions needed for steps 1 through 7 to occur. And we'll go through these steps in the next slide in a little bit more detail, and each specific step throughout the lecture a little bit more, especially the last 3 or 4. So I recommend having these steps written down as you go through the lecture so that you can refer to them according to the process that I am going to talk about. So if I'm going to talk about, for example, lithification, you'll be able to see when it falls within this sedimentary rock formation process. Before a sedimentary rock forms, the first thing that needs to happen is that there must be some rock of any type that is uplifted and exposed to the surface where it can get weathered and eroded. The weathering will be either physical disintegration or chemical decomposition, as we saw in the last chapter, or it can be an action of both on that pre-existing rock. So weathering generates many products subject to erosion, such as solid particles and also ions in solution, as we saw again in the last chapter. These are all then transported by some erosional agent and transport agent, such as gravity, water, wind, and ice. The main ones being water and wind, and later ice. And then these erosional and transport agents deposit the soluble or insoluble weathered particles in their new environment of deposition. So this deposition is what gives sedimentary rocks their name. Sedimentum in Latin means to settle. So here, for sedimentary rocks made out of insoluble particles, it means exactly that. When the transport agents no longer have the strength to carry the particles further, these settle down. They become sedimentum, as the Latin word says. But the deposition of material that is dissolved in water, so ions in solution, is not related to the decreasing strength of the transport agent, but rather to the removal of these ions by chemical or temperature changes, which causes that material to crystallize and then precipitate out of that solution, meaning again to solidify out of the liquid solution. That's what the precipitate means, and I'll be referring back to that again. So again, the material that's in the liquid precipitates out of it, meaning it solidifies out of this liquid solution and crystallizes. So another option for these dissolved ions that are in solution to deposit is when organisms remove them from this dissolved material in order to build hard parts such as shells and exoskeletons. So once deposited, there is burial of older material by younger material for either type of way in which the particles are deposited. And this will gradually lithify the material or make it into a rock. So this happens by the compaction and cementation. All of these changes are referred to as diagenesis, all the changes from the time that it weathers away until the time that it lithifies. And diagenesis is a word that means change of origin, and we'll continue to cover it later in the chapter as well. So because the products of weathering are transported, deposited, and then transformed into solid rock in a variety of ways, geologists recognize 3 different categories of sedimentary rocks. These categories are based on the sediment that makes up the rock, and on the processes that make these rocks lithify, so compact themselves and cement. If the sediment is of solid insoluble particles, these deposits are called detritus, and thus the category is called detrital sedimentary rocks. If the sediment is of soluble particles, usually ions in solution, then there are two different options. The first option is that the ions will precipitate out of the solution by chemical or temperature changes, in which case the rocks will fall into the category that is termed chemical sedimentary rocks. The second option for these sediments of soluble particles, again ions in solution, is that the ions in that solution are extracted by living organisms to build up the hard parts of those organisms, such as their shells or outer part of their bodies. So these still fall under the chemical sedimentary rock category, but they occur due to biological help. So I might refer to them as biochemical sedimentary rocks, okay? Okay. The last category is the organic sedimentary rocks category, and these are formed from carbon-rich remains of organisms. The primary example of this category is coal, and we will look at it further in detail later in the lecture. But these organic sediments are much different than the weathering-derived particles from pre-existing rocks, as you'll see. Alright, so in the next few slides, we'll start with the detrital sedimentary rocks, and then we will move on to the other two different categories. Okay, so the first one, again, is going to be the detrital sedimentary rocks. So here, quartz and clay minerals are the chief constituents of sedimentary rocks, even though other minerals and rock fragments can be found in them. So remember from chapter 6 that clay minerals are the most abundant product of the chemical weathering of those silicate minerals, especially the feldspars, which are in turn the most abundant silicate mineral in the crust of the earth. If you guys remember, feldspars were about 51% or so of Earth's crust. So clay minerals, because they're the weathering a product of the weathering of feldspars, are going to be abundant as well, especially at the surface. Quartz, the other most common mineral in sedimentary rocks, is common because it is extremely durable, and we saw that also in chapter 6. It is resistant to chemical weathering and it is hard. Other common minerals that are found in detrital sedimentary rocks are feldspars and micas. Again, micas are muscovite and biotite. And these feldspars and micas get weathered relatively easily, so their presence in sedimentary rocks indicates that their erosion and deposition occurred fast enough to preserve some of the primary material from the source rock before it got decomposed. So these pieces from other rocks that make up the detrital sedimentary rocks are referred to as detritus, the single pieces. So those are detritus, also called clasts. So sometimes the category itself is referred to as clastic sedimentary rocks, okay? Detrital or clastic sedimentary rocks. These detritus will then be cemented by the variety of materials which makes up the sedimentary rocks. And we'll cover that later. So the primary basis for distinguishing among various detrital sedimentary rocks is particle or grain size. So in the image above, you can see the size categories for distinguishing detrital sedimentary rocks, with larger sizes on the top and smaller ones on the bottom. Sizes so small that they cannot even be seen by the human eye without the help of magnification. Sizes allow us to classify them, but it also provides us with information regarding the environment of the position of said rocks. For example, currents of water or air sort the particles by size. The stronger and more energetic the current is, the larger the size that can be carried. And the weaker and more lacking of the energy that the current is, the smaller the size that it can carry. So in the next few slides, we are going to look at the main detrital sedimentary rocks, starting from smaller particle size to greatest particle size.